Now we're going to draw the halogenation reaction of an alkene. The molecule shown here is 4-methyl trans-2-pentene. We can see first of all that this double bond here is in the trans form. If we look at the main carbon chain, we see the carbon chain starting over here and it comes in from the top direction to the double bond. Then it goes out the other side on the bottom. So it transfers from one side of the double bond to the other side of the double bond. On this top side of the double bond, there's also a hydrogen that's implied by this structure, and on the bottom there's a hydrogen implied. This is called trans-2-pentene because we want the double bond to have the lowest possible number. So this is carbon 1, this is carbon 2, this is carbon 3, 4, and 5. So we go 1, 2, so our double bond is at carbon number 2, and then 4-methyl. The halogenation is the addition of Cl2 or Br2. And in this case, I'm going to add bromine. So we're adding a molecule of bromine across the double bond. In the case of alkene halogenation, because the double bond is an electron-rich area, that means that, or it is electron-rich because the double bond is made up of a shared pair of electrons for the first bond, and then a second pair is shared to make the double bond. So that excess of electrons makes it quite reactive. For the halogenation of an alkane, we needed a catalyst. For the halogenation of an alkene, all we need to do is expose the two molecules to each other, and we will get a reaction. This double bond will be eliminated, and we will end up with the main carbon structure in single bonds. So we'll be losing the double bond, we'll lose the alkene nature, and end up with an alkane-based molecule. So I've got our 5-carbon backbone, I've got my methyl group, and then the bromine will add where the double bond was. So the bromine is going to add 1 bromine atom at carbon 2 and 1 bromine atom at carbon 3 because that's where the double bond was. So I'm going to put a bromine right here, and I will put a bromine right here. The name of this molecule would be 2,3-dibromo 4-methyl pentane. And we have the bromines having the lowest number because the bromines take precedence over the methyl group. So the numbering remains as it was in the alkene, 1, 2, 3, 4. So 2,3-dibromo 4-methyl pentane.